Hello class, back again. So we're going to be looking at some simple logic and digital circuits. So in particular we're going to think about the basic circuit. We'll represent that as a logic gate. When we think about binary logic deals with binary variables. So we have a binary variable that binary variable can either be on or off. Now we represent these in the truth table as true if it's on or false if it's in an off position. So when we think about logic and digital circuits, we think about the fundamental constructs of those circuits, we really focus on three different gates. So we look at the AND gate, the NOT gate and the OR gate. So in the AND gate we're dealing with two input symbols, so we have X and Y. So these truth tables would have to represent every variable associated with that actual gate. So with the AND gate we've got true, true, false and false. With the Y we've true, false, true and false. So we can say X and Y. So the AND gate has a certain property that says that if we have two inputs, well, the result of that gate can only be true if both inputs are true at any given time. So we have true and true is true, true and false is false, false and true is false, and false is false. With the NOT gate, we simply have one input, we have X. X can either be true or false. In other words, X can either be on or off. And then if we think about not X, well, not X is going to be the negation of whatever the input was. So if we have true, well then not X will go to false. And if we have false, well then not false is going to be true. The last gate, or the last elementary gate that we looked at was the OR gate. So again, if we have two inputs, X and Y, we have true, true, false, false, true, false, true and false. So we can say X or Y using the plus symbol to represent OR. We can say X or Y, so the OR gate yields a true when either of the variables are true or both are true. So we have true or true is true, true or false is true, false or true is true, and false or false gives us out a false. So now we have our truth tables associated with our elementary digital circuits. So what we have to be able to do is to draw these elementary circuits. So if we have X and Y in an AND gate, if we take in an X, we take in a Y, but an AND gate looks something like this. And the result we write down the far side of the gate. So this here represents the AND gate. In the NOT gate we have one input symbol, X, coming into a NOT, which is represented as a triangle followed by a circle, and the result is X with a bar above the top. The OR gate takes in two inputs, so we have X and we have Y. We draw X and Y into the OR gate, which looks like that there, and again we write the resultant just after the gate. So we're all done, so we'll draw a little happy face.